Fuses, another basic component. This component is known by almost everyone. What's the main use of this? It's used to protect other components from overloading with excessive current that may cause those other parts of your circuit to blow up. Like you see some ICs like ICs we've just talked about. If you overload those ICs with some voltage and power beyond some certain thresholds, then they will just blow up. Well, fuses do come in wide range of sizes, shapes, and packages as well. We have THT as well as SMT packages. Also, we have like pluggable parts, as you can see them on the images there. Well, they are mainly like, they fall under the category of safety devices. So what are my pointers here on fuses? One, when you see an F in a PCB, be it SMT or THT, that will always be a fuse. Again, if you want to save on cost, again, you can assume not to include your fuses, but again, no, be aware of the trade-offs that you might blow up some very important components and end up replacing and wasting a lot of money. But anyway, in terms of saving cost, that's one of the components we do eliminate in the designs. What are varistors? Actually, this is one of the components that's not popular, and even most engineers don't know about this and they don't use it in their design. That one I can promise you, but it's a very useful component in terms of safety. You just go ask an engineer out there what's a varistor, they won't know, but I'm very sure it's a very important component in terms of safety. So in most cases, you'll see us, like, also you'll see me using it together with the fuse, because it has a way of increasing current that flows through the fuse so that it blows up very quickly in terms when we have a short or something. So we have a short circuit or something of the sort, then its resistance varies with applied voltage. So that's why it has that behavior. Where they also used to protect like devices from high voltage surges. And what do we mean high voltage surges? I mean, like when we have like a power loss and then power is coming in, because it's not regulated, we might have like spikes, power shooting more than 240 volts, more than your DC, say 12 volts, and that might end up damaging your components. So when you slot in a varistor there, again, it plays a very huge role in terms of safety. So it will just swallow down, I would say swallow all those surges, high spikes, and puts them to ground. So what are my pointers here? If you see VR on your PCBs, definitely that's a varistor. No other component has that reference designator. Well, again, if we want to save on cost, we can eliminate varistors, and maybe that's one of the reasons why most engineers don't use it. But again, that is attributed to like they don't know of its existence. An example of it in circuit here, we have, like I'm indicating here, a fuse holder and a varistor here. It's at the input of AC current. Yeah. So again, they play a very important role here in terms of protecting the input. Yeah, and actually note that they are mostly used at the input, not at the output. But again, we can have them at the output. So it depends with what you are driving and stuff like that.